In this video, we're going to work on finding the domains of functions. Now, what I've got starting us off right here is the three common domains, the three common things that happen with our domain. First, right here, we've got something linear. Its domain is all real numbers. Sometimes we use a Blackboard R for that, or sometimes we simply say it's the open-closed, clopen, osed, open, closed, set, negative infinity to infinity. Next, the other thing that we can have happen to give us actually some issues with our denominator is this. Now, what's happening here in this rational function is we've got division, and we can't divide by 0. So that means x minus 5 can't be 0, which means that x cannot be 5. So the domain of this function is everything less than 5 is fine, or everything greater than fine. That's fine too. So we do this infinite interval and we take 5 out. And if we're using the real number sort of notation for this, that's all real numbers minus 5, minus the set that contains 5 in set builder instead of interval notation. Okay, what's happening over here in this third example? In this third example, we have a square root. And if we restrict ourselves to real valued solutions, which a lot of times we want to, that means that 2x cannot be less than 0, which means that x cannot be less than 0 divided by 2. I'm solving. That means that x cannot be less than 0. So what's its domain? Its domain is all numbers that are not less than 0. It is allowed to be 0, and it's certainly, that's a lousy comma, and it's certainly allowed to be greater than 0. That's the domain. If I'm using set builder notation, I might say it's the positive reals plus 0. I might say it's the set of all x such that x is greater than or equal to 0. That would work too. So 3 different notations for this. Let's take a look at some other examples. Let's find the domain of this function. F of x is equal to x minus 7 divided by x squared minus 64. Now, this is our problem right here, is we've got this denominator that cannot be equal to 0. And we're going to figure out when that happens by solving. This is quadratic, so I'm going to factor it. So x plus 8 and x minus 8 cannot be 0. That means that x cannot be negative 8. X cannot be positive 8. Now, in set builder notation, this is pretty easy. It's the reals take away or minus, either works. Plus or minus 8. In interval notation, like the book uses, it's a little bit trickier. We have to say, okay, look, it's everything less than negative 8, everything between negative 8 and 8, and everything between, everything greater than 8. We can do better than that. There we go. So there's, we could call this a triple interval. And the idea is this. Here is a sandwich, right? A little bit of lettuce, maybe some cheese sticking out. Here's a sandwich. And then we go ahead and we make 3 cuts on the sandwich. We have 3 pieces. So that's why we have a triple interval. 2 cuts, 2 things that aren't allowed, gives us 3 pieces. Next, we're going to go ahead and we're going to take a look at this ugly, terrible, no good square root. And we need this whole thing here, x squared minus 3x plus 2, to not be less than 0. So I'm going to factor it. X squared minus 2 times x minus 1, x minus 2 times x minus 1. And then I have to think. If I have a positive times a positive, that gives me something positive. If I have a negative times a negative, that gives me something positive. These are the two situations that I want. What I don't want is I don't want a positive and a negative. That would be a negative. That would be bad. I don't want a negative and a positive. That also would give me a negative, and that would be bad. So, if x minus 2 is greater than 0, if x is greater than 2, and make that x minus 1 is greater than 0, x is greater than 1, I'm fine. So this would be the interval. Is it allowed to be 0? It's allowed to be 0, so this can be 2. 2 to infinity. And we could also have x be equal to 1. And so we're going to have plus just 1 in there. That would be fine. I could also have this situation where x minus 2 is less than 0. So x is less than 2. And x minus 1 is less than 0. X is less than 1. And remember, it's allowed to be 1. It's allowed to be 2. So 1, negative infinity, that's okay. So I think that gives me my interval. My interval is negative infinity, 1, unioned with 2, infinity. It just can't be in here where it's something like 1.5. Then this would be negative and this would be positive, and that's no good. Okay, so that's 2 examples of finding intervals. Thanks, and I'll see you next time.